You will notice on this problem that we do have an equation. We have an equals symbol. So we're going to solve, which means isolate the variable on one side. First, we will simplify if we can. When we simplify, we stay on 1/2. There's nothing to do on the left. Those are not like terms. But on the right, we can distribute this 3 to the parentheses. And 3 times 2x will give us 6x. 3 times 1 will give us 3. Parentheses comes off. We'll bring down the rest. And then we can combine the like terms on that side. So we have 6x plus 8 on the right-hand side. Now we'll bring down the left-hand side. This equation has a variable on both sides. So we're going to get rid of one of the variable terms, either the 3x or the 6x. It does not matter, but you want to make one of those cancel. I'll get rid of the 6x. That's how we started on the others. We were keeping the variable on the left, but it doesn't matter. So if we're going to get rid of the 6x, we're going to subtract it from both sides. I'm going to just put it after the one it's going to go with. So I'm subtracting 6x. That's my new step. Bringing everything else down. I have to do the same new step on both sides. And on the right-hand side, it cancels. That was the plan. On the left-hand side, we'll combine. Will give us a negative 3x minus 4 equals 8. And now we have a standard two-step equation. We will work on the side with the variable and first take off anything added or subtracted. So we're going to take off the 4. It's subtracted, so we need to add to make it cancel. So we're going to add a 4 on both sides. So this is what we had already. We're going to add a 4, bring our equals straight down, and add a 4 on the right-hand side. Clean up. Leaves us negative 3x equals 12. Go back on the side with the variable, and you're ready to divide out that coefficient. So we're going to divide on both sides by a negative 3 to leave us x equals 3 into 12 will go 4 times, and you only have one negative. That's odd, so negative. So x equals a negative 4. For our next equation, we don't have any simplifying on the left-hand side. They're not like terms. We don't have any simplifying on the right-hand side. So we're ready to start solving. We do have a term with a variable on both sides. So we either should get rid of the 7n or the 12n. I'm going to get rid of the 12n, and that will keep my variable on the left. So that's a positive 12n. I will need to subtract it on both sides to make it cancel. So I'm going to bring down what I have, and then I will subtract 12n. And I will also subtract it on the other side. On the right-hand side, it will cancel. That was our plan. On the left-hand side, you will have like terms. They are different signs, so they're going to subtract. Sign of the larger, keep your variable. And now you have a two-step equation to solve. So we'll work on the side with the n. We'll take off the 5 that's added. So we're going to take it away to make it cancel. So we had a plus 5. We're going to do a minus 5 to make it cancel out to 0. Do the same thing on the other side. I would not try to do it in my head. I would write it just because of your signs. And what you have there is you actually have like signs, so they're going to add and keep the sign. Then you're going to go back on the side with your variable, and you're ready to divide out your coefficient. So we need to divide on both sides by a negative 5. Will leave us just n on the left. On the right-hand side, 5 into 15 will go 3 times. We have two negatives, that's even, so it will give us a positive answer. Problem 25. We have another equation that has a variable on both sides. We need to get rid of one of those first. Either get rid of the minus 2y or get rid of the 5y. We'll go ahead and get rid of the 5y. That will keep our variable on the left. So it's a positive 5y. That means we need to subtract it. We'll bring down what we have, and we're going to subtract a 5y. Bring your equals straight down. We also will subtract a 5y on the right-hand side. That one cancels out. That was our plan. On the left-hand side, combine your like terms. The coefficients are also like signs, so they're going to add. Keep the sign, one copy of your variable. And now you have a standard two-step equation. Work on the side with your variable, and you're going to take off this 10 that's subtracted. So to make it cancel, you will add on both sides. Clean up. Gives us negative 7y equals 28. Go back on the side with your variable, and you're ready to divide out the coefficient. So we're going to divide on both sides by a negative 7. Will give us y equals 7 into 28 will go 4 times. There's only one negative. That's odd, so it is negative. This next problem looks a little shorter, but it has a tricky spot. So what you want to notice is it does have the variable on both sides. If we get rid of the one from the right-hand side, which is what we've been doing, we will add a 6 into both sides. And notice on the right-hand side, it wipes out. On the left-hand side, we'll clean up. We have different signs there. Subtract, sign of the larger. But you have to put something on the right-hand side. You're not allowed just to make your equals move over and have a side. So when something wipes out, you need to put 0 for that side, and then you'll be safe. Now we're going to work on this side with the variable, and we're ready to take off the 6. 6 is added, so we're going to take it away from both sides. Clean up. Says negative 2n equals negative 6. Back on this side with the variable, you're going to divide out your coefficient. So you're going to divide by a negative 2 to give us n equals 2 into 6 will go 3 times. You have 2 negatives, that's even, so it is a positive. For problem 27, we're going to translate from words over to symbols. This one is not an equation. I don't see anything that means equals there. So we'll just start off, and we have 3 times the difference. So times is our first operation. We can start with a dot for that. We have 3 times, and we expect the second piece of this multiplication. What we get instead is another operation or quantity word. Anytime that happens, the second one should go in parentheses because we want 3 times the whole thing. And then inside the parentheses, we'll translate that word. So difference is subtract. And it's going to go in order. And will be our separator. A number, so we'll use any variable we want. And 7. This answer is fine. It didn't say simplify. You could have it without the dot. If you did simplify, that would also be satisfactory. So 3 times x is 3x, and 3 times -7, -21. So either of those answers. You do need the parentheses, though, when you do the translation, because it's 3 times the whole difference. 28 is another translation problem. Our first word there is twice. Twice means 2 times. We're expecting the second piece of that multiplication. So here's our twice. What we get next, though, is another operation or quantity word. So that one will need to go in parentheses. Sum means add. And is your separator, a number, and 5. That answer would be fine. You could have it without the dot once you realized you needed the parentheses. You could simplify if you wanted. So distribute the 2 to x plus 10. Either of those answers is fine, but again, you need the parentheses because you're doing twice an entire quantity. Make sure that you do review all of your terms for your translations. Remember, your order matters with your subtraction and with your division. Watch out for the 2 subtract ones that go backwards. And our piece that's new, or our symbol that's new, is the equal symbol. So equals, gives, is or was, results in, amounts to, yields, is equal to. All of those give you the equal symbol, and that will help split your problem up if you see that it's an equation. We'll look at just a couple of easy solve problems for a formula. And these work exactly like an equation, except they have to tell us which variable to isolate. So this one says solve for r. That means we're going to isolate the r. So in our equation, we will go on the side with the r. Anything else on that side needs to cancel out. So we want to cancel the t. It's multiplied, so to make it cancel, we should divide by it. So we're going to divide on both sides by the one we don't want. I'm going to divide by the t. We'll clean up. That t cancels. It's okay that you have a fraction on one side. The r is isolated. That was your goal. One more formula to solve, and this one says that we're going to solve for a. So we're going to isolate the a. We should always go on the side of the one we want, so we need to be on the side with a. That means we don't want the b. The b is subtracted, so to make it cancel, we will add a b to both sides. On the left, it cancels. There's nothing we can do on the right-hand side because they're not like terms. A is isolated. That was our goal. For the last problem on this part of the review, just make sure that you review a word problem or two from section 3.4.